Both density and buoyancy describe why objects float or sink, so mathematically there has to be some relationship between the two, and that's what we want to derive today. What we have going on here is, let's say we have an object and we're going to place that object into a container of water. It could be any fluid. That'll make the water rise, so make the water level increase. And what we know is that the volume of the object is equal to the volume of the fluid displaced if the object is completely submerged in that fluid. So in this derivation, we must be completely submerged. Otherwise, the equation is not correct. Now, what we want to do here is we're going to look at our equation for density, which is mass over volume, and rearrange this to be that volume is mass over density. And so we will replace this volume with mass over density for the object, so O for the object, and F for the fluid. Now the next step is to multiply each side by the gravitational field. So we multiply on both sides, and as long as you do this to both sides, mathematically it's still equal. And finally what we see is this. Mass times gravitational field for the object, well, that's just gravitational force. And mass of the fluid being displaced times the gravitational field is the buoyant force. And there's a relationship. We have buoyant force and density. Now, the way that it's written on your equation sheet and the way that the book writes this is that the gravitational force over the buoyant force gives us the ratio of the forces is equal to the ratio of the density. So just rearranged a little bit differently. But in this formula, this gravitational force is the gravitational force in the air. And that'll make a bit more sense after going over a problem together.